Good morning. My name is Stefan, and I'm a member of the support team here at SeisWare. In the workflow today, I want to walk through our petrophysics capabilities. And to do so, I'll go through a net pay calculation, how we can generate that net pay map. Our petrophysics tool is called the Geology Calculator. And when you first open it up, it can seem a little bit confusing, but in its base, simplest terms, the Geology Calculator is just a Python-based application that allows for predefined calculations. You'll see them all on the left here. They're organized by folder, and they all come from Ross Grain's Petrophysics Handbook. In addition, since it's a Python-based application, users also have the ability to create their own custom work calculations. In today's video, I won't be covering kind of those custom calculations, but if you are curious about creating your own, please don't hesitate to reach out to our team. We're happy to help with that. So once we select a calculation, it shows up in the middle column here, where we can add multiple different calculations and create sequences. What's really nice about a sequence is you can run it all together, and it's easy to save these sequences or share them between different users and different projects. Once selected, every calculation shows up very similar. You start with the input variables, the top third here, and your input variables will always be log curves, aliases, constant values, or well zone attributes. In the middle portion here, it shows the actual equation. What's really nice here is that it's not a black box. So users have full ability to see what calculation is actually running on their data and edit it if they want. A nice note here is you also include general recommended parameters that are good for giving you a starting point if you're not sure what to start with for a certain calculation. And in the bottom third here, we have our outputs. You can output as a log curve, a well zone, or a well zone attribute. And here you can control all the specific parameters with that output. So the calculation I'd like to run today is just a basic net pay sequence. And you can see it takes a lot of different calculations. So in SeisWare, we define net pay as the summation of meters or feet, depending on which units you're working with, of pay along a well or within a zone along that well. To calculate the sum of meters of pay, we need to first find a pay flag, which defines where along the wellbore within the zone we define pay, based on this case on permeability, saturated water content, porosity, and volume of shale. To define all of these, I've created a log curve for each of those. So my water saturation, my permeability, my porosity, and the volume of shale all have come from these predefined calculations on the left here. So once I select my wells, I can go ahead and run this, and it'll generate all of these calculations together in sequence. While that's running, I'm going to show you what those generated log curves look like. So I have a cross section here, and you can see, as an example, I show my saturated water content, my permeability, my volume of shale, and my porosity all calculated from that calculation there, and the pay flag showing where and where not pay has been defined. I can also take a look on the base map. And here's where I can show that pay flag. So we like to show it as a ribbon in SeisWare. And how ribbons work is it's just a colored ribbon at each well zone. Using the color bar on the left here, you can see how many meters of pay there are within that zone at each well. We can then take this another step forward and use Quick Grid and Contour Tour to quickly create a net pay map. So I'll run this here. While this is generating, I just want to jump back to the Geology Calculator for a minute and show you how we can also, it's not just limited to petrophysics calculations. We also have examples where you can do some rock physics calculations, in addition to some general bulk data cleanup. So things like curve normalization or unit conversions between feet and meters and different conversions of the such. So while I've explained that, you can see we finished generating our net pay map. Looks a little bit messy here, so I'll just turn off those ribbons and those contours. And you can see a really clear, net pay map that was generated in just this workflow here. So in conclusion, I've shown today just a really quick introduction to our petrophysics abilities through the generation of a net pay map. If you have any questions, please reach out to us anytime. Have a great day.